Hi there and welcome to Math 2 Unit 3. This is going to be your Unit 3 review worksheet and some advertising here of course as well. We have our production Into the Woods coming up on September 27th through October 6th. So make sure you get your tickets and we'd love to see you out there enjoying the show. So here we go, a little review for this unit. Okay, I'm going to zoom in just a tad bit here and we're going to work through these problems for you guys. Alright. So given triangle EFG and is congruent to XYZ, find the measurement of angle X. Angle X is located right here on that little corner, which is between the 3 and the 2, 3 and the 2, so it's going to be right here. So we know E is going to be congruent to X. They're going to have the same size. So what do I know about this triangle? I know that I already have 90 degrees and I have 60 degrees, which adds up to be 150. But the sum of the angles of a triangle is going to be 180 minus 150, so I have 30 degrees remaining, and that will be my answer for number 1. So the value of measurement of angle X equals 30 degrees. Number 2 says measurement of angle R right here and measurement of angle W are both 35 degrees. There's 35, 35. The measurement of angle V and angle S are both 72 degrees. 72 degrees. RT here is congruent to UW here. Okay, so that one's congruent to that one, and we can see if that's 3, then this is also going to be 3. What is the length of VU? So VU is this length right here, which is the long side coming off of the 72 but not hitting the W, 35. So it's going to be congruent to this long side coming off the 72 but not hitting the 35. If this one is 5, then the length of UV is going to be equal to 5. Okay, just make sure you have your corresponding parts corresponding and connecting the right way. So this is matching that one right there. Number 3, to prove that triangle KLM is congruent to KLN, which triangle congruent postulate could you use? Okay, what we'd want to use here, we have an angle and we have an angle. So we know we have an angle, we need something else, and we have another angle. I need a side right there. And so we would say, let's use this side, and the reason we would use that side right there is because of the reflexive property of congruence. It says that this line is equal to this line because it's the same line. So we'd say angle side angle for number 3. Number 4, it says name all the corresponding congruent parts given triangle RST is congruent to FEG, and write another congruent statement. Right, so if I was to list it out like this, RST is on top of FEG, we would say that RS is congruent to FE. I could say that ST is congruent to EG, right? Yep, FEG. And then I could say that T, the first one, back to the last one, the first one, TR is congruent to GF. And that works there. In terms of the angle measurements, we could say that angle R is congruent to angle F, angle S is congruent to angle E, angle T is congruent to angle G. And in terms of another congruent statement, I could just change the order of things. I can go STR for the first one, STR, and follow the same pattern. We would say EGF for the second one. Okay? Different. You can do different ones if you wanted to, but the order is important. Just keep the same order there. Next one, choose all the corresponding statements given that MON is congruent to PQR. So let's do the same thing. Let's stack this up and write MON right there. Okay, so my lines all line up, and here's the parts I'm talking about there. So is M congruent to P? Yep, it's the same one. ON here to here is congruent to QR. Yep, ON, QR, same one. Off we go. MN, skipping there, so maybe going the other way, congruent to PO. That's not even on the right triangle, so we would say nope. You have NOM going this way, congruent to RQP. Same order, same direction, everything lines up. We would say yes. Measurement of angle O, congruent to measurement of angle R. Nope, not in the same column, not going to work. and then we have ONM, ONM, and then RPQ. It's all mixed up, we would say no. All right, number 6. Look at number 6. In the diagram, what is the measurement of angle DCN? So the measurement of DCN right here, that's the question we're being asked. First of all, if I have 68 and 75, and I have this line that's crossing there, possibly these are going to be matching angles there, but let's take a look. I could do it a certain couple ways. I could say that 75 and 68 add together to give me 143. If that's the case there, then I have 180 minus 143, which is equal to 37. So this angle measurement here is 37, which makes this a vertical angle, and that's also 37. Because this has one little curve there, it's indicating to us that this is also 68 degrees in that space. So I have 68, 37, 68, 37, and still what's missing is that 75 to match over there. That's my matching part. So we would say that measurement of angle DCN is equal to 75 degrees. By definition of congruence, what additional information is needed to know that the triangles are congruent? You might want to know that DC, the length there, is congruent to SR. Might be good to know that. You also might want to know that DN is congruent to SN. Might be good to know there. And it might be also good to know that measurement of angle DNC right here, is congruent to measurement of SNR. Those are some various things you might want to know to prove that those are going to be congruent triangles. Okay, so let's look at the next page. Page 2, flipping it over here. And so we have a diagram where we have two polygons there that are very similar, and they're supposed to be, but they've been shifted around a little bit. This polygon here has been rotated, looks like about 180 degrees to make it flip over on its side. Okay, that means that this part right here, this line GF, is going to correspond to this line right there because we flipped it over. Okay, it's standing up. That's the idea. So let's find the value of x. To find the value of x, first of all, we're going to say that this line 12 is equal to the value of this line, which is 2x minus 4. So to solve for this, we'll add 4 to both sides, add 4, and 16 equals 2x. To solve for x, we divide both sides by 2, and that leaves us with 8 equals x. So we got that part, no problem. Now, using this information, we will solve for y. Now the trick with the y is that I have to make sure I'm looking at the right angle. It's this acute angle right here that when I rotate it around lands right here. And so in this case we can say that 68 degrees is equal to 6y plus x. Do I know the value of x? I sure do. It's 8. So we'll erase that and we'll put an 8 right here. Now I'll subtract 8, and I have 60 equals 6y. I'll solve this by dividing both sides by 6, and so I end up with 10 equals y. So there's my y value, and there's my x value for this shape there. Number 8, which postulate or theorem can be used to determine if the measurement of r given the measurement of O is determine the measurement of r? It's how do we find out what that is if we're given that O is congruent to L. So when we look here, we have an angle that's congruent, we have a side that's given that is congruent, and we want to be able to prove that that is congruent there. So there's a couple ways of looking at it. We could perhaps consider an angle side, and the reason we say angle side is if I could show that these are vertical angles, if I can show those are vertical angles, then I'd have an angle, and a side, and that would let me know that that's going to be equal there. I could also use the idea that corresponding parts of congruent triangles are congruent, and the reason for that is I have, in this case here, if I can prove this here, I really have perhaps alternate interior angles. I could look at this guy and that guy as matching, and I could say that's going to work as well. So a couple ways you might be able to show that that's the case. This could be corresponding parts, or it could be alternate interior angles are congruent. Okay, a couple ideas. That's a different question. I wasn't really quite sure what they're asking exactly, but just makes you understand the different postulates and theorems we've talked about in class for this unit. Number 9, find the value of x. Okay, we have 2, 2, 1, 1. So my 5x is going to go right here in that space right there. So I'm looking for that missing angle measurement. What I'm given is I have 80 and I have 45, which is 125. I subtract that from 180 to see what the value of that space is going to be. And when I do that, I have 55. Not done yet. That's just the value of that space. I need to find the value of x. So 55, I'm going to set it equal to the corresponding angle here, 5x. I'll divide both sides by 5, and we have 11 equals x. So my value for x is going to be equal to 11. All right, this next section, it says to choose the postulate or theorem you would use to prove each pair of triangles are congruent, and then write a congruent statement. If there's not information, write not information. So in this section here, the things you're considering, if you look back at your notes, are things like side, 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 angle, side, angle, side, angle. We might have angle, angle, side, and you might have the hypotenuse leg as the postulates or theorems that would allow you to prove that these triangles are going to be congruent. Those are some of your options here as you go through this. Okay, so just recall that from, I think, your worksheets like 3A, B, C, D, E, F, G, all the way to elemental P. Here we go. So for the first one, number 10, we can see that we have a side, a side, a side, and a side. And what we're lacking here would be an angle, but these are both vertical angles, right? Those are vertical angles there. So I would be able to prove they're congruent by a side, angle, side theorem. And what you're going to do in part B is you're going to just write down the letters of the triangle in the right order. So we have RSQ, for example. RSQ is congruent to triangle, and because I started over here, I'll go here, TSU. TSU. All right, looking at number 11. Number 11, we have an angle. We have a side, side, and a right angle. When I have a side, side, and a right angle, and I include in that the hypotenuse, we call this a hypotenuse leg theorem, right? So this would be my hypotenuse leg, is what I'm going to call that there. For the triangle, maybe I go the short to the middle to the long, and I can do E, F, D. And I make that congruent to triangle, short to middle to long, G, F, H. That's just one way. It's a triangle. You could start at any point as long as they're going to correspond to one another. You're in good shape. Here, I have a side, a side, and a side, and a side. What I'm missing is this third side. But because of the reflexive property, I could say that that MP is equal to PM. Once I know the reflexive property is going to work there, I could prove this is a triangle and it's congruent by side, side, side. I'm going to let you figure out the triangle part there. Over here I have two parallel lines, and because I have two parallel lines, I have these transversals that are flying through there, going through there, and I have this guy here. I've got lots of stuff going around. Okay, so what do we know to be true? We have an angle, we know we have a reflexive property there, so that's going to be equal to whatever it needs to be equal to. And then because I have these transversals that are going through parallel lines, potentially I could say that I have alternating interior angles like so, and I have angle, 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 side, perhaps is what I have. I think I'm not quite right on that one actually. So my notes, I definitely do say angle, angle, side. So that could be what it is. What's a good question to ask is, do you know if these two lines are actually, yeah, we do. We know they're congruent because of this. Sorry about that, I'm just thinking too much while I'm talking. Because that is equal to that, then we know these lines are going to be transversals, which makes those alternate interior angles equal as well. So anyways, moving on to 14. 14, we have, this is chopping this in half from what we can tell. We have a reflexive property there. So we have a side, and a 90 degree. When I have the hypotenuse as one of my sides and the leg, this is my hypotenuse leg theorem, and you need to make your triangle work out the way it's going to work. Over here, we have a side and an angle, but I also have the vertical angle here, which means I have side, angle, angle. or sorry, we'd actually go angle, angle, side, how we call that one of our choices. Angle, angle, side. And that's my choice there for number 15. Flipping it over to the back side. Number 16, we've had one like this already. We knew that we can use reflexive property there, and as a result, we're going to have angle, side, angle is how that's going to work out there. Over here, yes, these look a lot alike, but this is actually a reflection. And when it's a reflection, then the parts aren't matching. It's a mirror image. So this is going to be a not congruent thing. It's not going to be the same because it's a reflection. So it's not going to work there. All right? It's a little different there just because of what it is. So we're going to say not congruent because it's a reflection. And number 18, we'll look at this one here. This is a rotation, but it is keeping everything proportional. I know there's a squiggly line there, but you can live with that squiggly line. The idea here is that I have a side, an angle, a side, angle, side is what I can use to prove that those are going to be equal to each other. Now let's move on to some proofs, because you will have some proofs today, and you'll have some proofs coming up in some other assessments as well. First, you begin with what's given, and you have to copy that over. So we say that AE is congruent to CE, and we can say that AB is congruent to CD. Okay, there's my part that's given. I also know that E is the midpoint of BD. That's given. So what I know so far is that I know that that matches that matches that, and this is the midpoint right there. Because that's the midpoint, I can say that BE is congruent to ED, and that's the definition of midpoint. That means that this matches this. As a result, I can say that the triangles are congruent because I have side, side, side. And that's how I prove that that is congruent. Number 30, a lot of given information. We know that AB and DC are parallel. We know that angle B corresponds to angle D and that they are equal. We know that, then we have to prove, we're trying to prove that BC, this guy here, is congruent to that guy there. All right, let's do it. Well, first they said that BAC here is equal to ACD there. So those two are going to be equal to one another because alternate interior angles are congruent. These are alternate interior angles. That's my line, all right, my transversal. Here's my parallel lines there, and these are alternating across the transversal, and they're both inside of the parallel lines. So we know that's true there. We could also then say that AC is congruent to AC right here because it's reflexive. So now I have an angle and a side. Okay, so the triangles are equal because of angle, angle, side. Knowing that the triangles are equal, I can now say that this part matches that part because corresponding parts of congruent triangles are congruent. Okay, finally let's look at number 21. We have what's given. We can say that step 1, angle K is congruent to angle M, as KL is congruent to ML. This is what's given first of all. So we know that that matches that and that matches that. Okay, sounds good. I also can say that this angle matches that angle. So we can call that measurement, measurement of angle JLK is congruent to measurement of PLM. And that is because why? Vertical angles are congruent. And now that I have an angle, a side and an angle, we can say, step 3, triangle JKL is congruent to triangle PML, and the reason for that is angle, side, angle. And that's our rationale for that one. All right, let's turn the page. Getting closer, about halfway through. Okay, number 22. Number 22, it says to name a common angle for TPQ and RPV. So what we have is we have a couple different shaped triangles here, right? We have a triangle right there, right? We cut that off, we have a triangle there, and then we also have a triangle here. And we want to ask We're asking what is a common angle, one they both share together without being a corresponding, just in common. They have the same one. And in this case, we would say it's going to be angle P. So if you look here, we have to find where is P in the middle of these measurement statements. And there it is, T, P, Q, and that's going to be our answer there. For number 23, looking for a common side of RST, so that's this triangle. So I just draw it real quick like this, common side, and UTS. So here, well, which one do they double up on? They double up right here on that line right there for ST. So we would say D is going to be the common side. That's where they cross over. 24. So it's given that AD is congruent to BC and ADC is congruent to BCD. Okay, name a pair of overlapping congruent triangles. So our overlapping one, if it's DAC, our overlap is going to be CBD here. And then state whether they're congruent by side, 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 and all these fun things there. Well, we're going to say they're congruent because they share that side, the overlapping side there, common side. And so we have side, angle, side for how they are congruent. For number 25, we can say that JK, this long bit right there, is congruent to KL, this long bit there. And then KN, the short side, is congruent to KM, that short side. Okay, so we're trying to prove that MKL is congruent to NJK. MK, get this right. MKL, sorry, is congruent to NKJ. Sorry about that. NKJ. And we're going to prove this is true because we have a short side and a long side, and we also have a common angle right there. So if I looked at this triangle, I have an angle, long angle, or long side, an angle, and a short side. So it's side, angle, side is how I'm proving those are congruent shapes there. All right, number 26. It says graph a triangle whose vertices have the coordinates -3, -1, 5, -1, and 4, 3. So to do this, we're going to go over, in this case here, we're going to go 1, 2, 3, and down 1, and this is what we plot at A. Okay, I can zoom in a little bit because it's a little bit tiny. Let's see this work. Yeah, there we go. We're in business. So there's A. B is at 5, so 3, 4, 5, and -1. So there's my B. And C is at 4, and down at 1, 2, 3. So there's where C is at right there. So that's my triangle ABC. There we are. And we're going to reflect this over the y-axis and name it A prime, B prime, C prime. So here's my y-axis. We're going to reflect that right over there. So to do this, one of the easiest ways is to see how far we are from the y-axis. In this case, we're away 1, 2, 3. So I'll go this direction, 1, 2, 3, and put a point there, and we'll call that A prime. B is 5 away, so 3, 4, 5, and so that's B prime. And C, we said was 4 away, so it goes right there as C prime. And we connect our dots, and that's what it looks like when we reflect it over the y-axis as such. For the next one, we do a couple steps here. First, we're going to graph this one, and we have -2, 1 is where point A is at, and then -4, so 2, 3, 4, 3, 1, 2, 3 is where B is at, and then -4, same spot, -1 down here is where C is at. So my triangle looks like this, okay? Good so far. Now the next step, it says, is we're going to rotate 90 degrees clockwise, then translate it with a +2 and a -1. Okay, so let's do this here. If you're going to talk about rotating and translating things, sometimes it's helpful to just maybe visually see this here. If this is my initial triangle, here, here, and here, and this is my origin right there. If I rotate this 90 degrees, I put a pencil down there, and I'm going to rotate it clockwise 90 degrees until my T snaps in place, and I land right about there. Okay, now this isn't my answer, that's just the first part of my answer. My first part translates it to there. But now I need to move 2 to the right and then 1 down. So I can take this and slide it 1, 2 to the right, and then translate it 1 down, so I'm right there. Now I can go back and I can lift up my paper here, and I can see that, okay, well, that's going to be here. Oops, not very good at this. That's going to be there. This one's going to be on the same line but one away from the y-axis, right about there. And then we'll drop down 2 and be here for this one right there. Make sure I got my dots right. Yep, sure did. And then we can play connect the dots for that one, and that one. And again, this becomes my A prime, this becomes my B prime, and my C prime. So I first had to do a rotation, which put it over there, and then I had to slide or translate it over that direction there. That's how we do number 27. Let's take a look at number 28. Okay, and we're going to map ABC over to DEF. To map ABC to DEF, what's taking place here? How are we going to do this here? We want to write a congruence transformation that maps one to the other. So we're taking this shape and we're going to get it over to there. There's a couple ways of doing this, so it's up to you. What do you see is kind of what you want to think about. You might see that this triangle here, when I look at this triangle, if I was to overlay that on top of this one, I can't get it to match up without doing what? Without a reflection of some sort. If I reflect it, I can get it to line up right there on top of it. So I know I'm going to have to do a reflection. Okay? So I can go ahead first of all, and I could just reflect this shape across the x-axis or the y-axis to get it something like that. That could work, right? Maybe that works, or maybe, well, catch the y. Maybe it'd be better, let's take a look, then give me where I want to go. Maybe I take it here, and let's reflect it across the x-axis. If I do that, and I flip it across there, hey, now we're going the right direction, aren't we? Right? That shape there is lining up to that shape. So we're going to first step is we're going to reflect over the x-axis is the first step. So to draw that out, I would put it maybe here, right? And this guy is 1, 2, 3, so 1, 2, 3 away. And this one is at 1, 2, 3, 4 away, 1, 2, 3, 4 away. So if I redrew that, my first step would be reflected across the x-axis, so I have it there. And then I need to translate it that way. So what am I going to translate it by? I'm going to say it's an x plus 1, 2, 3, 4, 5, x plus 5, and the y stays the same. So I'm moving to the right 5 units to the right. Okay? 5 units to the right. Translate 5 units to the right is the idea. Going from there to there is the idea. So I think I did that right. I hope so. So I translate it right that way. Okay, now let's look at 29. 29, we're going to map ABC to DEF. Again, this one here, we take a look at it, and if you want to make a little picture of it first of all, we have a picture here, we have this guy, we have this guy. If I take that triangle, I can get it to line up, but I have to flip it, don't I? It's going the wrong direction. So there must be a reflection at some point to make this work. I also notice that I can spin some things too. If I was to rotate this around the origin and have that snap into place, something like that, what I could notice is that, gosh, I'm pretty close to having a rotation of 90 and then a mirror image across the line. And that's actually what's going to take place. If I rotate this around the origin, I end up placing the triangle here, and that's my rotation of 90. Something like this is my rotation of 90. So step 1. So rotate, and we're going to be going 90 degrees counterclockwise, direction matters, about the origin. And then step 2, we're going to simply reflect across the y-axis. Right, here's our y-axis, so we'll reflect across there. And we can see that that's true because this is 2 away and that's 2 away. So we are going to reflect across the y-axis. And then it's going to line up where it needs to line up. Okay, so that's the idea for number 29. For number 30 and 31, they're a little bit more complicated. There's more things happening here, and there's a variety of ways to get to the solution you want. So you can look at that. Again, it's really up to you. What do you see? Okay, what do you see? I know that I have to go from here, in this position, and I have to get that guy to line up over here somehow. So to make this work, what could work is I could reflect this over the x-axis first, okay? And in this case here, is this going to be, yeah, because it's isosceles, it doesn't really matter. I can reflect it across the x-axis, and by doing that, I land about there, okay? Something like that, no, 2. So I land there. Now that I've landed there, in this place, here, 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 I can then translate over 1, 2, 3, 1, 2, 3 to the right and 1 up. So I go 1, 2, 3 to the right and translate 1 up. So that could work. It's an idea. So one solution could be to reflect over the x-axis, okay, and then 2, we're going to translate the shape, and we said we were going to go x plus 3 and y plus 1 to get to the new shape, the new position. Again, that's just one way of doing it. And for 31, the same idea here. We have this crazy shape there. You're probably going to want to take it, and if we look at DEF, and we see what we have here, DEF, if I take that shape and I reflect it over the x-axis, okay, then I end up landing somewheres about here, okay, and so I'm getting closer. So here I am at this place. I'm drawing it. Yeah. So, oh, sorry, there. Get to that point and that point. And now that I'm here, I could take my shape, and if I rotated it, right, I rotate it around this way. And it looks like if I rotate it, I'm not quite sure. That much? Hard to say. Rotate it and then translate it. This one I had trouble with. When I kept playing with it, I just couldn't get to line up the right way. Like, that's pretty close, but then I would have to rotate it and then translate it down 2 over 1. And I still am not comfortable with a triangle shape. So play with it a little bit. I just had trouble with this one myself. It just wasn't a very clear copy for me to make it work. But you're probably going to have a reflection, a rotation at some point about the x-axis. So see what you can come up with there to make that work. One possible idea you might want to consider for this one could be to rotate it counterclockwise. So you rotate it counterclockwise about 90 degrees about the origin. So that would be taking our shape and go counterclockwise 90 degrees. So this way 90 degrees about the origin. That seems to get you pretty close in terms of alignment there. And then if we went down 1, 2, 3, we're getting pretty close to where we need to be there. Mine doesn't quite line up, but it gets me close. I wish it was perfect for you, but sorry, it's just not. So that's where I end up at. Okay, so then you go down 3. Down 3. My notes say go down 3 and right 1. Just not quite sure if that's going to be right. So that's a good one to kind of ask and look at. These triangles just bug me. Moving on. Enough of that. I'm going to zoom out. And here we go. Number 32. We're solving for x and y. We have an isosceles triangle. If this is isosceles, then my value of x is going to be 50 because those are going to be equal. So I've used up 100 out of my 180 possible inside the triangle. And what's left is 80 degrees, so y is going to equal 80 degrees. Over here, I have equal angles, which means I have an equilateral triangle. So all these are going to be equal. So to find x and y, I can say 8 equals 2x minus 5 to solve for x. And I can say 8 equals y plus 3 to solve for y. So I can add 5, 8 plus 5 is going to be 13 equals 2x, divide by 2. And so 13 over 2 equals x. Or I could say that's also 6.5. For this one, I can subtract 3, and I have 5 equals y, and I'm done. So those are my solutions for number 33. For number 34, this will become a supplementary angle, so I want to see what's left. If I know it's supplementary, it's 180 minus 115, and I subtract, and I have 65 as my measurement there. If that's 65, and this is an isosceles triangle, then x equals 65. Now what's left, I have a 65 and a 65, and that's going to be 10, 12, 13. So what's left is going to be 180 minus the 130 that I've used for a solution of 50. So y equals 50 degrees there. So x is 65 degrees and y is 50 degrees. All right, let's turn the page and we're on our last page for the review. If you're hanging in there with me, you're getting them all right and you're ready to go for your tests coming up. So number 35. We have 42, 69, and I'm not sure what this angle is going to be, but let's find that out. So if I begin with a 69 and a 42 and I add that up, I have 11, 10, 111. So I take 111 away from 180 to find out that this space right here is a 69. Because that's 69, that means that this length is going to be the same as that length there. So that would mean that 2x plus 25 is equal to 5x minus 2. That side equals that side. I can set them equal to each other, and now I can solve for x. So I'm going to subtract 2x, okay? That 5 minus 2 becomes 3x, and this one goes away. And I want to get the whole number over there, so I'll add 2. 25 plus 2 is 27. Bring my equal sign down. So 27 equals 3x. Divide both sides by 3 to get x by itself, and x is going to be equal to 9. Looking at number 36, similar idea. Here we have two angles are the same, telling us this is going to be isosceles, which makes that value equal to that value there. So we'll set them equal. 5x plus 2 equals 7x minus 4. I'm going to go ahead and move the 5x over here by subtracting 5x from both sides. That goes away. 7 minus 5 is 2x. Now let's get the whole number over there. Plus 4 plus 4. So 6, bring that down, equals 2x. Divide both sides by 2. And 3 is the value of x for that one there. Number 37. We have 17 and 17, which means these are an isosceles triangle, and it wants them to measure the base angles. If the top is 50 and my angles on the bottom are the same, I'm going to do 180 minus 50 for 130. Then I want to divide that by 2 because there are two angles there. 130 divided by 2 is equal to 65 degrees. For number 38, we have to make sure this is isosceles. Let's find out. We have 72 plus 36, this and this, equals 108. So 180 minus 108 is going to be equal to 72. So that's that. So this and those match, which means this side equals that side. I needed to check that out to know which ones to set equal to each other. So 4x minus 2 equals 3x plus 5. I'll subtract 3x from both sides. So I have x there. Now let's move the 2 over there. So x is going to equal, bringing that down, 5 plus 2 is 7 for number 38. Number 39, we have 68 and x, this thing here, those are corresponding, or the isosceles, which means our base is here, right? So that's my top. 180 minus 68 is going to tell me what's left for the two bases. When I subtract that, I end up with 112, and I need to divide that by two angles. So 112 divided by 2 is equal to 56 degrees is my value for x there. And number 40 here is an interesting one. It's just interesting. Your teachers might change the numbers on here because they end up with a crazy solution. Let's just show you how you do it. 58 plus 64 is going to equal 12, and we have 12, we have 122. Great, that's there. So what's left is 180 minus 122, and we have 8 and 58, so 58 is there. Doing everything right so far. That means that these sides are going to be equal to each other. If you do this though, you get 4x plus 12 equals 3x plus 5. The math says, okay, let's do it, minus 3x. So we end up with x here, right? And there's our equal sign. That goes away. We subtract 12, and negative 12 plus 5 is a negative 7. Now that's a crazy solution because you can't have a negative value for a distance. If I plug that into these equations, I end up with a negative number. So this is the math that's working, but it really becomes a no solution because there's not that value doesn't come out to be a positive number. And if you're measuring a length, you need a positive number. So it's kind of a weird problem. Probably one of these was written wrong. So honestly, I just wouldn't worry about it too much because doing the math right is important, but the solution just doesn't quite work out. Hope that helps you out for your tests, and good luck. Study hard, ask questions if you got them, and we'll see how you do later. Thanks.